guys, what's up? Shreyas here. Today we are going to discuss about physical science or physics, right? So in the previous video we had discussed about 3D printing. For that video just click here. Okay? So we shall start our journey through physical science or physics. Okay? So let's get started. The basic concept of mechanics is that a force applied at one point can overcome friction, gravity, and other forms of resistance to produce motion at another. This physical law has been long understood, and inventors have devised machines in order to amplify the effect, allowing larger amounts of resistance to be overcome with less power. Archimedes, a Greek mathematician, made early strides in understanding the mathematics underlying physics. Legend has it that while bathing, he was inspired by observing the displacement of water. His insights helped in hydraulics and in the basic principles of leverage as well. He determined that the force needed to leverage an object declined with its distance from a fulcrum. In the 1500s, Nicholas Copernicus and subsequently Galileo Galilei and Johannes Kepler revolutionized humankind's understanding of the solar system and the rules regarding planetary motion. Their work relied not just on astronomical observations, but on experiments with moving bodies and an understanding of inertia and the effects of force over distance. In 1665, Sir Isaac Newton began 2 decades of thought and experimentation that resulted in a set of universal laws of physical science, culminating with the 1687 publication of his Philosophiae Naturalis Principia Mathematica. Newton provided the mathematics of how objects, including the planets, move and interact, tools and concepts still vital to science and engineering today. Scientists have refined and explained on Newton's law and their implications, but all mechanics is fundamentally about motion. Closely related to all 3 of Newton's law of motion is the concept of work. To a scientist, work necessarily involves a motion, which is produced in a given body by an external force that is applied at least partly in the direction of movement, and that is measured as a transfer of energy between the objects. Thus, work might involve compressing a gas, rotating a shaft, applying leverage, or countless other movements or operations necessary in a society that depends on machines. 2 other concepts critical to Newton's law of motion are force and inertia. Force is any action that has the ability to maintain, alter, or distort the motion of an object. Force has magnitude and direction. Inertia is a property inherent in a body by which it opposes any impulse to begin or change in movement. A Newtonian definition of work given in terms of force and inertia applies to many realms of the physical world, including the efforts of this 1943 prison work crew. So what is hydraulics? So, a French mathematician and philosopher Blaise Pascal laid the foundation for modern hydraulics, which studies the special properties of liquids. Pascal in the mid-1600s determined that the pressure applied to a liquid in confined space is transferred equally throughout the substance. This principle, which allows the transfer of amplification of force through liquid-filled chambers, has broad applications. Pascal himself invented the syringe and the hydraulic press, and hydraulic systems are common in today's automobile braking and steering systems. Decades later, Swiss physicist Daniel Bernoulli examined the properties of water in motion, showing that pressure decreases with velocity, a fact that explains the movement of water through pipes, and since air rushing across a wing is subject to the same role is basic to aerodynamics and flight. Bernoulli's principle, named for the Swiss scientist Daniel Bernoulli, describes the movement of fluids and around moving objects. Essential to airplane design, Bernoulli's principle helps engineers analyze turbulence. Physics is the study of what the world is made of, the underlying stuff that gets turned into stars, planets, and people, and how it functions. It thus serves a set of ground rules for chemistry, biology, and other sciences. Early natural philosophers, as scientists once were called, relied largely on argument as opposed to experiment, with Chinese, Indian, and Greek theorists proposing different basic ideas about the nature of matter. The debate was particularly vibrant in Greece around the 55th century BC, when Parmenides' followers, who argued that all in nature came from combinations of earth, air, fire, and water, debated those of Democritus, who believed the world was made of indivisible units he named atoms. In the late 18th century and early 19th centuries, this debate was resolved in Democritus' favor when Henry Cavendish and Anthony Lavoisier showed that both water and air could be broken down into other components, one of which Lavoisier named hydrogen. Based on those and other findings, English school teacher John Dalton surmised these substances were made of basic elements or atoms. Early in the 20th century, Ernest Rutherford argued that even atoms have parts: protons, neutrons, and electrons. Scientists then posed the question, what holds this all together? Beginning in 1864, James Clerk Maxwell developed equations showing that electricity and magnetism act together to produce electromagnetic waves. Electromagnetism is now recognized as one of four basic forces that hold matter together, along with so-called strong and weak forces which act on the subatomic scale, and gravity, which acts across cosmic distances. The foundation of quantum mechanics, a field based on the knowledge that the basic particles of matter behave more like waves, was laid by researchers such as Niels Bohr and Werner Heisenberg in the 20th century. Quantum mechanics united electromagnetism and light with atomic structure. What is string theory? So, the search for a common thread by which to explain the universe has turned into just that, a theory stating that gravity, electromagnetism, and the strong and weak forces that hold atoms together all connect through the vibrations of infinitesimal strings of energy. Though without empirical proof of so far, string theory is rooted in 1960s research that found that the mathematical model describing the bond between protons and neutrons suggested energy to be a vibrating filament. String theorists hypothesize that his connective tissue works across as many as 11 dimensions, all but 3 so small they cannot be seen. What is a quark? So early models of the atom were fairly simple, with neutrons and protons forming a nucleus and negatively charged electrons orbiting in what seemed like a tiny solar system. In the early 1930s, however, analysis of cosmic rays and experiments with particle accelerators began revealing new particles by the dozen. American physicist Murray Gell-Mann in the early 1960s conjectured that protons and neutrons were made of even more fundamental particles, which he dubbed quarks, a word borrowed from a James Joyce novel. He suggested that 6 flavors of quark were needed to explain atomic behavior: up, down, top, bottom, sharp, and strange. All 6 have since been identified through experimentation, carrying a fraction of the charge of an electron. The up and down quark are the constituents of protons and neutrons. So who is Albert Einstein? Albert Einstein is a relativity theorist. Born in Ulm, Germany, Albert Einstein studied at the Zurich Polytechnic Institute and was working as a patent examiner in Bern when at age 26. His articles on special relativity were published in the German journal Annalen der Physik. The work had its origins in a thought experiment he had conducted at age 16, when he imagined riding on a beam of light and puzzling about how, even though the speed of light is a constant, a parallel beam would have seemed stationary. Einstein's theories of special and general relativity ultimately united matter with energy and space with time. They redefined how gravity works, and they also helped usher in the age of atomic energy and weapons. Once Albert Einstein said that if A is a success in life, then A equals x plus y plus z. So work is x, y is play, and z is keeping your mouth shut. Okay? It was a nice joke, okay, said by Albert Einstein in 1950. So I hope that till now you have understood somewhat of physical science or physics, right? So okay guys, so meet you in the next video. Till then, stay safe from COVID-19 and please like the video and please subscribe to the channel, okay, and watch this and this video too, and please subscribe to my channel, okay.